All right, next up, number 7. Again, find all solutions on the interval 0 to 2 pi. Okay, notice with this one we've got both sine squareds and a regular sine of x in the equation. Now I can't combine the two of these aren't like terms, just like I can't add x squared plus x together. It is what it is. So that's how I know this is going to be one I need to factor. And since it's 3 terms, I'm going to be factoring into binomials, basically reverse foiling. Now let's see how to do that. Okay, for the first multiplications, I need to get to a 2 sine squared x. Now the only nice way to do that is going to be to do a 2 sine x times a sine x. Okay, because 2 sine x times sine x will be 2 sine squared x. And to get to the 1, I'm going to have a 1 and 1. Now 1's got to be positive, 1's going to be negative. And the trick is going to be figuring out where that is. Now since I want a negative sine squared, I know I'm going to need the 2 times the negative, the plus 1 here. And I should never factor incorrectly, because once I factor, I can always check and make sure I did it right. If I do my first multiplication, 2 sine x times sine x, it's going to give me a 2 sine squared x. Outer, 2 sine x times 1 will give me a negative 2 sine x. Inner, we get a plus sine x. And yes, that will turn into a negative sine x, which is what I was looking for. 1 times negative 1 is a negative 1. Okay, so we know we factored it correctly because it foils back out to what we started off with. Now remember, other thing I could do is if I don't like factoring with the signs, is I could ignore them and just rewrite this as 2x squared minus x minus 1 equals 0. Okay, factor that. And then just replace the x's with the signs once again. Okay, so don't let the factoring part of this problem stop you. Now the reason we factored is once I have things in factored form, I can find the zeros of the individual factors. So I'm basically breaking this down into smaller, simpler problems. So now I want to solve 2 sine x plus 1 equals 0. And then also sine of x minus 1 equals 0. Let's do that. 2 sine x plus 1 equals 0. We'll subtract 1 from both sides. They'll give me a 2 sine x equals negative 1. I'm going to divide both sides by 2. And that'll give me a sine x equals negative 1/2. Okay, so there's my simple trig equation. We'll graph that out. Now, where is sine going to be negative? Well, that's going to be when the opposite side is negative, so that'll be in the bottom 2 quadrants. Because both of these, like we said, would have that negative opposite side. Okay, sine is opposite over hypotenuse, meaning my opposite side is a 1. My hypotenuses are 2's. Okay, that means my adjacent sides have to be root 3's because we're talking 30, 60, 90's. Okay, and then the solution I'm actually looking for is this angle in standard position. So we could say x is equal to a 180 plus 30, in other words 210 degrees, which if I convert, I end up with a 7 pi over 6. Then also if we keep that going, we'd have another x equals to 360 minus 30, because I'm 30 short of a full rotation, which is 330 degrees. And if I convert that, I'd end up with an 11 pi over 6. Running myself out of room here. All right, so that's my solutions from the first factor. Both these two answers would make this factor 0. If a factor is 0, the whole thing's 0. Okay, for my second part then, we'll add 1 to both sides. We want to know where sine of x is equal to 1. Now, anytime you're talking 1, 0, negative 1, you can't have a triangle where the opposite over the hypotenuse is equal to a nice number like that. So that's why I'd recommend to go to our graph of the sine function. Remember, sine was the guy that looked like this. Okay, we want to know where it's equal to 1. Well, that's going to be whatever this value is. Okay, I know sine takes 2 pi units to repeat itself. So that means the middle would be a pi. So this would be a pi over 2 for that part of my solution. Okay, so final answer then, we'll say x is equal to 7 pi over 6, 11 pi over 6, and pi over 2. All right, there's all my solutions from both factors. We're talking between 0 and 2 pi, so we're not worried about adding any 2k pi's or anything like that to it.